All right, so this is from day 14, Piecewise Functions. We're going to be looking at a cool down called International Postage. So we're dealing with functions who are defined as different pieces. If we take a look at this, on some graphs they have this continuous like increasing like this, but often in the real world you'll find situations where your outputs actually make these jumps and then they stay flat for a while. So this is an example of a situation where we'd have a piecewise function. So the train fare, how much you pay to go on the train, is a function of how old a kid is. It's free for children under 5. It's $5 for children who are at least 5 but younger than 11. And it's $7 for children who are at least 11 but younger than 16. The graph, as we can see over here, is composed of pieces or segments. These pieces could be connected or disconnected, but when disconnected, the graph appears to have breaks or steps. We would call this like a step graph. So here's a graph that represents F. Now, free from 0 up to 5 years. These open circles here tell me that when I get to 5 years old, I have to jump up to the next level. And this solid dot tells me that at 5 years old, it costs $5. We have another jumping point. So from 5 years up to 11. So the moment the kid hits 11 years, we have to jump up to the next level. This open circle tells me that there's not actually a point here. I have to go up to where the solid dot is. So at 11, it jumps up to the next level. And then when you hit the age of 16, you start paying adult prices. It's important to consider the value of the function at the points where the rule changes or where the graph breaks. Like I said, at 5 years old, we're not free anymore. We jump up to the next level. At 11 years old, it's not $5 anymore. We have to jump up to the next level. And then again, here at 16, it's not $7 anymore. You probably have to jump up to the adult price after that. We can show a piecewise function written out kind of like this. So we can say that f of x is equal to, and then we use this squiggle bracket to show that we're going to use multiple pieces. Well, it's 0 from 0 to 5 years old. And this is a less than and a less than, so 0 and 5 are not included. If a kid hasn't been born yet, you're not going to be paying for their ticket. And if they're 5, we have to jump to this next level. So it's $5 when x is greater than or equal to 5, but less than 11. So at 5 and up to 11, and then at 11 we jump to the next level again. So you can see on the graph, open circle, jump to the next level. That's shown by this. It's less than and then less than or equal. So if we take a look at this, on the graph, the point 50 is marked with an open circle to indicates not included in the first segment. Again, 0, 5, not included. We jump to the next level. This is how we write it. I think that's it for that. So we have a very similar situation here. P of W is the function that gives the cost in dollars of mailing a letter from the United States to Mexico in 2018 based on the weight of the letter. For a letter that weighs between 0 and 1 ounce, up to and including 1 ounce, it's going to cost $1.15. So if I were to draw this on the graph, from 0 to 1 ounce, it's $1.15. So not including 0, because if it's equal to 0 ounces, we're not mailing anything. Up to and including 1 ounce, it's $1.15, and I know that's probably not exactly where $1.15 is, but you get the idea. And then from 1 ounce to 2 ounces. Okay, so let's see. From 1 to 2, $1.72. That would be like right about here, I think, and then we would keep going. How much does it cost a letter to send a letter that weighs 1.5 ounces? How about 2 ounces? Sketch a graph. I hope that helps. If you have questions, let me know.